Cognitive development is a field of study in neuroscience and psychology focusing on a child's development in terms of information processing, conceptual resources, perceptual skill, language learning, and other aspects of brain development and cognitive psychology compared to an adult's point of view. In other words, cognitive development is the emergence of the ability to think and understand. A large portion of research has gone into understanding how a child imagines the world. Jean Piaget was a major force in the establishment of this field, forming his theory of cognitive development. Piaget proposed 4 stages of cognitive development: the sensorimotor, preoperational, concrete operational, and formal operational period. Many of his theoretical claims have since fallen out of favor. However, his description of the more prominent changes in cognition with age is generally still accepted today. Perhaps equally importantly, Piaget identified and described many cognitive changes that must be explained, such as object permanence in infancy and the understanding of logical relations and cause-effect reasoning in school-aged children. The many phenomena he described still attract the interest of many current researchers. In recent years, however, alternative models have been advanced, including information processing theory, neo-Piaget, theories of cognitive development, which aim to integrate Piaget's ideas with more recent models and concepts in developmental and cognitive science, theoretical cognitive neuroscience, and social constructivist approaches. A major controversy in cognitive development has been nature versus nurture, that is, the question if cognitive development is mainly determined by an individual's innate qualities, or by the personal experiences. However, it is now recognized by most experts that this is a false dichotomy. There is overwhelming evidence from biological and behavioral sciences that from the earliest points in development, gene activity interacts with events and experiences in the environment. Historical origins: Piaget's theory of cognitive development. Jean Piaget believed that people move through stages of development that allow them to think in new, more complex ways. Sensorimotor stage. The first stage in Piaget's stages of cognitive development is the sensorimotor stage. This stage lasts from birth to 2 years old. During this stage, behaviors lack a sense of thought and logic. Behaviors gradually move from acting upon inherited reflexes to interacting with the environment with a goal in mind and being able to represent the external world at the end. The sensorimotor stage has been broken down into 6 sub-stages that explain the gradual development of infants at this age. Birth to 1 month. Each child is born with inherited reflexes that they use to gain knowledge and understanding about their environment. Examples of these reflexes include grasping and sucking. 1 to 4 months children repeat behaviors that happen unexpectedly because of the reflexes. For example, a child's finger comes in contact with the mouth and the child starts sucking on it. If the sensation is pleasurable to the child, then the child will attempt to recreate the behavior. Infants use their initial reflexes to explore their environment and create schemes. Schemes are groups of similar actions or thoughts that are used repeatedly in response to the environment. Once a child begins to create schemes, they use accommodation and assimilation to become progressively adapted to the world. Assimilation is when a child responds to a new event in a way that is consistent with an existing schema. For example, an infant may assimilate a new teddy bear into the putting things in the mouth scheme and use the reflexes to make the teddy bear go into the mouth. Accommodation is when a child either modifies an existing schema or forms an entirely new schema to deal with a new object or event. For example, an infant may have to open his or her mouth wider than usual to accommodate the teddy bear's paw. 5 to 8 months child has an experience with an external stimulus that they find pleasurable, so they try to recreate that experience. For example, a child accidentally hits the mobile above the crib and likes to watch it spin. When it stops, the child begins to grab at the object to make it spin again. In this stage, habits are formed from general schemes that the infant has created, but there is not yet, from the child's point of view, any differentiation between means and ends. Children cannot also focus on multiple tasks at once, and only focus on the task at hand. The child may create a habit of spinning the mobile in its crib, but they are still trying to find out methods to reach the mobile in order to get it to spin in the way that they find pleasurable. Once there is another distraction, the baby will no longer focus on the mobile. Toys should be given to infants that respond to a child's actions to help foster their investigative instincts. For example, a toy plays a song when you push one button, and then a picture pops up if you push another button. 8 to 12 months behaviors will be displayed for a reason rather than by chance. They begin to understand that one action can cause a reaction. They also begin to understand object permanence, which is the realization that objects continue to exist when removed from view. For example, the baby wants a rattle, but the blanket is in the way. The baby moves the blanket to get the rattle. Now that the infant can understand that the object still exists, they can differentiate between the object and the experience of the object. According to psychologist David Elkind, an internal representation of the absent object is the earliest manifestation of the symbolic function, which develops gradually during the second year of life, whose activities dominate the next stage of mental growth. 12 to 18 months actions occur deliberately with some variation. For example, a baby drums on a pot with a wooden spoon, then drums on the floor, then on the table. 18 to 24 months children begin to build mental symbols and start to participate in pretend play. For example, a child is mixing ingredients together but doesn't have a spoon, so they pretend to use one or use another object to replace the spoon. Symbolic thought is a representation of objects and events as mental entities as symbols, which helps foster cognitive development and the formation of imagination. According to Piaget, the infant begins to act upon intelligence rather than habit at this point. The end product is established after the infant has pursued for the appropriate means. The means are formed from the schemes that are known by the child. The child is starting to learn how to use what it has learned in the first 2 years to develop and further explore their environment. These 6 sub-stages represent the approximate growth a child undergoes during Piaget's sensorimotor stage from birth to age 2. Once the child gains the ability to mentally represent reality, the child begins the transition to the preoperational stage of development. Preoperational stage lasts from 2 years of age until 6 or 7. It can be characterized in 2 somewhat different ways. In his early work, before he had developed his structuralist theory of cognition, Piaget described the child's thought during this period as being governed by principles such as egocentrism, animism, and other similar constructs. Egocentrism is when a child can only see a certain situation his or her own way. One cannot comprehend that other people have other views and perceptions of scenarios. Animism is when an individual gives a lifeless object human-like qualities. An individual usually believes that this object has human emotions, thoughts, and intentions. Once he had proposed his structuralist theory, Piaget characterized the preoperational child as lacking the cognitive structures possessed by the concrete operational child. The absence of these structures explains, in part, the behaviors Piaget had previously described as egocentric and animistic. For example, an inability to comprehend that another individual may have different emotional responses to similar experiences. During this stage, children also become increasingly adept at using symbols as evidenced by the increase in playing and pretending. Concrete operational stage lasts from 6 or 7 years until about 12 or 13. During this stage, the child's cognitive structures can be characterized by group therapy. Piaget argues that the same general principles can be discerned in a wide range of behaviors. One of the best-known achievements of this stage is that of conservation. In a typical conservation experiment, a child is asked to judge whether or not two quantities of the same, such as two equal quantities of liquid, in a short and tall glass. A pre-operational child will typically judge the taller, thinner glass to contain more, while a concrete operational child will judge the amounts still to be the same. The ability to reason in this way reflects the development of a principle of conservation. Formal operational stage lasts from 12 or 13 until adulthood and are advancing from logical reasoning with concrete examples to abstract examples. The need for concrete examples is no longer necessary because abstract thinking can be used instead. In this stage, adolescents are also able to view themselves in the future and can picture the ideal life they would like to pursue. Some theorists believe the formal operational stage can be divided into two subcategories: early formal operational and late formal operation thought. Early formal operational thoughts may be just fantasies, but as adolescents advance to late formal operational thought, the life experiences they have encountered changes those fantasy thoughts to realistic thoughts. Criticism: many of his claims have fallen out of favor. For example, he claimed that young children cannot conserve numbers. However, further experiments showed that children did not really understand what was being asked of them. When the experiment is done with candies, and the children are asked which set they want rather than having to tell an adult which is more, they show no confusion about which group has more items. Other theoretical perspectives on cognitive development. Speculated course systems of cognition. Empiricists study how these skills may be learned in such a short time. The debate is over whether these systems are learned by general-purpose learning devices, or domain-specific cognition. Moreover, many modern cognitive developmental psychologists, recognizing that the term innate does not square with modern knowledge about epigenesis, neurobiological development, or learning, favor a non-nativist framework. Researchers who discuss course systems often speculate about differences in thinking and learning between proposed domains. Researchers who posit a set of so-called core domains suggest that children have innate sensitivity to specific kinds of patterns of information. Those commonly cited include number. Infants appear to have two systems for dealing with numbers. One deals with small numbers, often called subitizing. Another deals with larger numbers in an approximate fashion. Space. Very young children appear to have some skill in navigation. This basic ability to infer the direction and distance of unseen locations develops in ways that are not entirely clear. However, there is some evidence that it involves the development of complex language skills between 3 and 5 years. Also, there is evidence that this skill depends importantly on visual experience, because congenitally blind individuals have been found to have impaired abilities to infer new paths between familiar locations. Visual perception. One of the original nativist versus empiricist debates was over depth perception. There is some evidence that children less than 72 hours old can perceive such complex things as biological motion. However, it is unclear how visual experience in the first few days contributes to this perception. There are far more elaborate aspects of visual perception that develop during infancy and beyond. Essentialism. Young children seem to be predisposed to think of biological entities in an essentialistic way. This means that they expect such entities to have many traits such as internal properties that are caused by some essence. Language acquisition. A major, well-studied process and consequence of cognitive development is language acquisition. The traditional view was that this is the result of deterministic, human-specific genetic structures and processes. Other traditions, however, have emphasized the role of social experience in language learning. However, the relation of gene activity, experience, and language development is now recognized as incredibly complex and difficult to specify. Language development is sometimes separated into learning of phonology, morphology, syntax, semantics, and discourse pragmatics. However, all of these aspects of language knowledge, which were originally posited by the linguist Noam Chomsky to be autonomous or separate, are now recognized to interact in complex ways. Worf's hypothesis. Benjamin Worf, while working as a student of Edward Sapir, posited that a person's thinking depends on the structure and content of the social group's language. In other words, it is the belief that language determines our thoughts and perceptions. For example, it used to be thought that Greeks, who wrote left to right, thought differently than Egyptians since the Egyptians wrote right to left. Worf's theory was so strict that he believed if a word is absent in a language, then the individual is unaware of the object's existence. This theory was played out in George Orwell's book, Animal Farm. The pig leaders slowly eliminated words from the citizens' vocabulary so that they were incapable of realizing what they were missing. The Worfian hypothesis failed to recognize that people can still be aware of the concept or item, even though they lack efficient coding to quickly identify the target information. Quine's bootstrapping hypothesis. Willard Van Orman Quine argued that there are innate conceptual biases that enable the acquisition of language, concepts, and beliefs. Quine's theory follows nativist philosophical traditions, such as the European rationalist philosophers, for example Immanuel Kant. Neuroscience. During development, especially the first few years of life, children show interesting patterns of neural development and a high degree of neuroplasticity. Neuroplasticity, as explained by the World Health Organization, can be summed in 3 points. 1. Any adaptive mechanism used by the nervous system to repair itself after injury. 2. Any means by which the nervous system can repair individually damaged central circuits. 3. Any means by which the capacity of the central nervous system can adapt to new physiological conditions and environment. The relation of brain development and cognitive development is extremely complex and, since the 1990s, has been a growing area of research. Cultural influences. From cultural psychologists' view, minds and culture shape each other. In other words, culture can influence brain structures which then influence our interpretation of the culture. These examples reveal cultural variations in neural responses. Figure-line task. Behavioral research has shown that one's strength in independent or interdependent tasks differ based on their cultural context. In general, East Asian cultures are more interdependent whereas Western cultures are more independent. Hedden et al. Assessed functional magnetic resonance imaging responses of East Asians and Americans while they performed independent or interdependent tasks. The study showed that participants used regions of the brain associated with attentional control when they had to perform culturally incongruent tasks. In other words, different neural paths used for the same task were different for Americans and East Asians. Kobayashi et al. Kobayashi et al. Compared American English monolingual and Japanese English bilingual children's brain responses in understanding others' intentions through false belief story and cartoon tasks. They found universal activation of the region bilateral ventromedial prefrontal cortex in theory of mind tasks. However, American children showed greater activity in the left inferior frontal gyrus during the tasks, whereas Japanese children had greater activity in right inferior frontal gyrus during the Japanese theory of mind tasks. In conclusion, these examples suggest that the brain's neural activities are not universal but are culture-dependent.